Hello everyone, welcome back to my channel. My name is Atul. So this is chapter 4. In chapter 4, what we are learning? So in our old lessons, what we learned minikube installation, and on the minikube we ran the cluster and we ran our Kubernetes command. So this is a new lesson number 2. So this is lesson number 1 and this is lesson number 2. And soon we'll be covering Kubernetes on VMware. So in lesson 2, so again we will be following like a master and a cluster kind of node. So this is master and this is worker 1 and this is worker 2. And all kubelet is installed. So this is a way like our Kubernetes cluster which will be deployed in AWS. So we'll be doing this lab in AWS, but before moving forward, so you have some prerequisite and some theory. So what all we'll be doing, and so at the time of doing like you'll be able to understand so what is going on. So as usual, so I'll be going through all the commands. So within 10 minutes, 10 to 15 minutes, we will be able to provision our entire cluster. So in case if you get all command, definitely you guys will be also able to provision your Kubernetes cluster with 3 node cluster within 15 to 20 minutes or 10 to 20 minutes depend upon the network speed of each and everyone. So what are the prerequisite? So prerequisite is, first of all, I'm using RHEL 9. So all the repositories are respective to RHEL 9. And in case someone having some different OS like RHEL 8 or RHEL 7, we have to use those repositories. So it's a minimum is 2 GB RAM, 2 CPU, and 20 GB free disk. So 10 GB is also okay, but we are recommending like 20 GB should be free. Okay, so what we are doing now? So deploy cluster on AWS RHEL 9 with the help of kubeadm. So it's a kubeadm is the utility or Kubernetes software which we'll be using, and with the help of kubeadm, we'll be installing Kubernetes cluster. Okay, so in this we'll be using 3 RHEL 9 instance with the below configuration. So what will bring, it's a node 1 will be master node and node 2 will be worker node and node 3 will be worker node. So in first will be master node, and second will be worker 01 and worker 2. So worker 1 and a worker 2. So whatever the IP comes given by the AWS, we'll be updating here. Okay, and we'll be changing the host name like with the help of hostname command, so that whenever we run some command, so it will be visible like we are running firing some commands on master or worker 1 or worker 2. So after setting up the host name, we'll be checking its connectivity, and we'll be whitelisting all IP address in a security group of AWS. Okay, then we'll be changing some host entries in a host file. Suppose this is a master one, so DevOps Lab ITS. So this is just a common name what I have taken. And when we will pinging, we'll be checking whether all the nodes are reachable with each other or not. In case if these servers are not reachable with each other, then our cluster won't work perfectly. So in order to do any experiment or do some installation, these all three should communicate with each other. Their pinging or maybe port should be open. So what our port should be open, we will be discussing in a. Okay, so Kubernetes, whenever we install Kubernetes, so like in swap file should be disabled. So swap should not be there. Okay, and SE Linux, and here I'm writing like in all host. In all host means all master and 2 worker. And whenever I see in a master host only, so means it in a master host only. Okay, so it's here we'll be disabling SE Linux, and in a master host we'll be adding some kernel modules. So whatever like a kernel modules are access setting, so they are used to like install the Kubernetes, and they are, you can say like they are the supporting files. Okay, so we have installed this kernel modules, and in order to make them like permanent, so we will be creating one file, okay, it's configuration file, and we'll be doing it. So and so we'll be adding some IP forwarding kernel parameters here. So these are the kernel parameters, and so whatever the parameters we have added here, so we'll be loading all those parameters. Okay, add firewall rules to master node. So whenever we install master node, so at that time, so we have to add some firewall rules. So these are the firewall rules. So right now in AWS, I have seen it's already firewall is already disabled. And in case if somebody get a server in yeah, somebody has started firewall settings, so we have to add these firewall settings permanently in the firewall settings, so that these are the ports should be opened. Else, in case these ports are not opened, then our cluster will create a problem. So in order, it will not be able to interact with the API server or API server will won't be able to interact with some more ports or services which are configured in these ports. 6443 is a major port on which, and to the worker node. So worker node also these many ports are required to be open. And in case if we have a firewall team or maybe some other places where we are installing, so these ports should be open. Okay, but right now this one and this one is not required because AWS firewall is already disabled when we take RHEL 9. Okay, so this were our like a runtime environment. For runtime environment, container D will be taking. Okay, so here in this way we will be adding a repository, a repository which is available in Docker CE. So once we install the repository, then we'll be installing a container D. So container D is installed. Once container D is installed, then we'll be starting their services. Then let's read configuring system D C group so that whenever container D start, it will start with system D configuration. So they are system C group configuration. So whenever our container D start, it should start with system D C group setting. So this is a basic command which will be firing while doing installation. And then we'll be as post installation and configuration, then we'll be restarting container D. And now let's move to Kubernetes repo. So Kubernetes repo is by default, it is not coming in Linux OS or RHEL 9. So we have to add a repository. So this is a repository, what we'll be adding. So this is the entire repository we'll be adding. And with the help of this repository, we'll be installing kubelet, kubeadm, and kubectl. So kubectl we already aware of, like a kubectl get node, kubectl get pods. Kubeadm is a utility which is used for Kubelet is a utility which is used to install the Kubernetes clusters, and Kubelet is a agent. So in case if we won't install this agent, this our worker node will be only be able to communicate to the master. And disable exclude is equal to Kubernetes. So disable execute here, it won't creates a problem to any existing Kubernetes repo. Okay, now enable kubelet service. So when we have here install the kubelet service, but here we'll be enabling and starting kubelet service. So now kubelet is installed. Now we have to initialize the cluster. Initialize the cluster means install the cluster. So as I said earlier, kubeadm is used. So here kubeadm will be using, and so what we'll be using, master01.devops. So here we will be giving that where control plane is to be installed in master. In case if we give any other server IP or server name, then it will be installing that Kubernetes master in another node. So here we have given master 01. So this one, so this is a box, this line and this line. So some settings are coming from the Kubernetes cluster. So so I just copied and pasted. So you guys also copy paste because again here too many things are coming. So like a Kubernetes join master. So suppose we have a three master, we want three masters, so we'll be getting this command. In case some more master we need to add, so we have to run some more master command in another master 02, we have to run this command. And in case if we wanted to, then you can join any number of worker nodes by running the following on each node. So in case if we have two worker nodes, so we have to run this command. In case if we run this command, so all the two worker nodes will come under control with master. Then we'll be firing Kubernetes get node. So how many cluster? Okay, and what happens? So this is not sufficient. So there are too many network settings also required apart from that, like Candy Calico, VNet, Flannel. So too many. One of the network setting also required. So this is again a queue. So whatever the server we have installed, it's known about their local host settings, like local host IP. But we need another settings or another network setting for this one. We need to install some network settings which is required by Kubernetes. So Calico, Flannel, VNet. So these are the major component or major like a network which is coming in the market. But this time we'll be using Calico. Okay. So and the cube system, it's a default namespace as we discussed. So we'll be checking the pods. It should be running. And this is a watch command. So what will happen with the watch command? With the help of watch command, we can once a pod is initialized, it will take some time. But when we want it to continuously monitor, so we'll be using watch command. And this is the like a single command. Okay. So whatever the token, so this is called as a token. This is called as token. So in case if we so token, we need to use those token to install it in the worker node so that this will be joining the master. and we wanted to, then we need to use the same token in worker 1 and worker 2. Okay, then we'll see like a kubectl get node. So all the nodes will be coming in a ready states. Okay, so now here again as again a deployments we have done. So now and later on what we'll be using? We'll be using SSH configuration. So what it mean here? So this one, some because what happened when we create a AWS machines like one master and two nodes. So we wanted to communicate with worker when sometime we need SSH of worker one from master node, but it won't allow simply. So we need to do some settings so that more all the time we don't need to give like a PPK file or private key. So without in order to be in case if we enable the setting, then PPK file is not required. Then simply like a SSH, then username at the rate IP address or maybe host name. That is enough. So why I'm telling this one? So because again, whenever we shut down the machine, not all the time we can do the experiments or maybe labs at the time. Like a public IP will be attached to it. So what I want, like a one public IP should be attached in master node, or maybe we can remove the public IP from other node, but enable the settings first. So master node, so one public IP is required and n number of private IP can be possible. So we just hoping one hope to another hope we will be taking. Okay, let's move toward AWS console. Okay, so right now I don't have any servers associated with it, so I will be creating some servers. Mm. Okay, so let's launch, create one master node, master 01. Okay, and then Red Hat I have chosen. So this Red Hat will come, and as I said, like T2 dot medium. T2 dot medium is sufficient because again it's a 2 virtual CPU and 4 GB RAM. So this one 2 CPU and 2 GB RAM is sufficient, but here I'll be taking 2 CPU and 4 GB of RAM. And the key pair, so I don't have any key pair. Let's create a new key pair. So here I'll be using PPK. Let's save it somewhere, and we'll be using. So this is called as a private key. I'll show you what is this. This is a private key. It is used to log into the server. Okay, so network setting again a subnet it's not preferred. So what we'll be using? We will be creating a security group. So at the time we'll be creating a security group, new security group, and allow SSH traffic from my IP. So here there are two settings like anywhere or my IP. So in case if you leave it like anywhere, then what will happen? Some hacker may try to hack your system. So always use my IP. So right now, in case if we choose this one, so the AWS server have access to our IP only. So in case some other PC will try to access this server won't be accessible. So this is additional layer of security. So nothing more. We will be just launch that instance. So this master 01 will be launching soon. Okay, and so see it will come soon. Okay, so it is starting master 01 is started. Then we'll be using worker. Here we need two servers, and both of them is RHEL. T2.medium. This is our key pair, and network setting we will be selecting our existing one. This is launch wizard one. So this is a security group what we created earlier, and let's launch it. Let's verify one setting, worker 0. Worker 0, why I have added here? So later on, once two servers, this is number of instance 2, because one server come, then we'll be defining 01 and 02. Okay, so Red Hat and 9 and 2 CPU and 4 GB RAM. Yes, it looks good. Then launch the servers. Okay, you can see like this server started running and what will be changing to 01 and here 02. Okay, so now our we'll be preparing the lab. So these all the IPs. Well, let's see. These are the IPs or what is coming. So right now, let's take the remote of the server with the public IP right now. Okay, earlier I shared like this is a MOBEX term. MOBEX term is a tool which is required, which we'll be using for taking SSH because again this make us gives us a easy. Okay, so this one is a EC2 user and this is master 01. Okay, so and here I forgot one thing. So here we need to give our private key. Here I've used a private key. So you can use private key and you can explore and you can give. Okay. So here we have given and as remote host we have given and something I think a master session name we have given. So it will be easy for us. Let's remote get inside the machine. Okay. So it has we arrived here and we are able to see this is a master we are on master 01. Now we have IP of worker node as well, so just added the session. Okay, and this is worker 01 and let's change the setting from here. Okay, so this one is also EC2 hyphen user, else it will create a problem. This one also EC2 hyphen user, so we can by default we can add the username so that it will not create a problem. So here worker 01, let it load automatically. It loaded. Okay, now worker 2. Okay, so this is the reason because again all the servers will be available to me in the tabs. So one, two, three. Because right now we need to learn, we need to fire some more commands. So that's why it will be easy for me to fire the command in the tabs. Okay, so now as per our SOP, let's move forward. And so this part is already done. Cluster, okay, so this is done. Okay, so what we'll be doing, we'll be changing the host name of the cluster and we'll be doing some settings so that whenever we doing settings, so it looks like we are working on master. So right now you can see like it's not look like what we are working on, it's a worker 1, but here it should reflect in host name also. Okay, so what I'm doing the changes in host name CTL. Okay, so I'm just going moving toward a root. Let's move toward root for each and everything. So now host name is converted. Okay. So, but it is not still not showing like master 01. So let's exit and you can see master. See master 01. So what we say that master, we are on master node. So now in the same fashion, let's move toward. So this is worker 1. Now let's move toward worker 2. Okay, so let's see. It's a master 01, worker 01, and worker 02. So all are looking like it's okay. So now, now first of all, we need to check the ping connectivity, and we need to update our settings, like what are their IP address, and we need to first whitelist all IP private IP address and security group of AWS firewall. In case if we want to, it won't communicate with each other, and we have to update the host file also. Okay, so let's first of all, like I'll be making an entry in of the like a private IP. This is private IP of this one. See, third one, and private IP of this one, and a private IP of master. Okay, so so this is all done. Okay, so let's go toward the security group of the AWS, and let's see we can update. So, but main thing is I have created security group, and the same security group I have added in all the servers. So you can see like launch wizard 1, launch wizard 1, and here also launch wizard 2. So means whenever we are making a cluster, so our security group should be similar, should be same, or in case if it's different, but make sure like connectivity should be there. Okay, so I'll be making some changes so that our cluster will be whitelisted. So this is our inbound rules, and maybe you guys already learned about AWS. So in case if then let's enable all traffic, or here this is master 01. In case we can do one more thing, we can add the entire subnet like 3100. So sometime people will be creating a problem, getting problem. So that's why I'm not adding the entire subnet. So I'm just adding all things slowly so that everyone will be able to perform the lab. This is worker 01. In same fashion, we'll be adding worker 2. Okay, this is all about this is my IP. Okay, so one more thing, like this is I've enabled SSH, so this is my IP. In case if you give anywhere, then it's very dangerous. So don't use this one. Use my IP only, or maybe some settings which will allow only limited resources to the server, like limited laptops or limited IP to this laptop. In case if you won't do it, it will be your servers in risk. I'm saving all the rules. Now let's go back to our SOP. Now, so we have whitelisted. Now, what we need to do? We need to create a host file so that our servers can interact with the help of DNS. So we don't have right now DNS, and so that we'll be going on a host file. Okay. So since we already updated the IPs, so we can update the IPs here. Okay. So so this is a whole host file in case if we don't have DNS. So for the local communication, this will be helpful. Okay, I'll show you this file. So what we have written, their individual IPs, master IP, DevOps worker 1 IP, and worker 2 IP. Now let's try to ping the servers. Okay, let's ping itself. See, it's pinging. So it means communication is happening. So this one we need to repeat this process in all the servers. Why? Because we want like all the servers to be communicate, because what will happen in case the servers won't communicate, later we'll come to know, and it's a very big mess. Then we'll be wasting some entire time why our cluster is not working, because again communication will not be happening. So we have to make sure what will be checking here. It should be pinging. Okay, I'll show like here, let's master 5, so nothing is coming. Okay, so in this one master we have checked, and worker 01, so it's communicating, and it's also communicating. So now we are good. So here now in let's erase it. Okay, now disable the swap file in all the boxes. So swap off. Okay, now what we are doing, we will be entering the swap file entry in etcfs tab. Okay, so again disable SE Linux, but in all the hosts. So let's start from master. Okay, then we'll be making an entry inside the config file, etc SE Linux file, to make it permissive. So these are the like disabling as SE Linux. So SE Linux again, you can assume like it's kind of firewall which will be creating problem while installing some application. So in order to escape from that, we will be disabling SE Linux. Okay. Now in master host only. So these are the kernel modules. So some of the kernel module. Let's install in a master only. Okay, and then mode pro VR filter. Okay, again. So this is like a temporary way. Like again, we'll be creating one Kate's cons file to in order to make it a permanent. But we'll be installing in a master node only. Again, some more kernel parameters which is useful for IP forwarding. So this is we have installed in a master only. So in master host only, it's because these are the parameter what we have defined. Now we'll be loading all parameter with the help of sysctl command. This all parameters are loaded. So here we can see like in AWS, I'm not able to see any firewall. In case if firewall is there, we need to add this entry. But we are skipping all those entry because AWS doesn't have firewall. Let's check it. So it's not found. So that's why we'll be skipping it. Now we'll be using a containerd as a runtime environment. So, but again, it's not available. So we'll be downloading its repo. But what we have to do, we have to install it in all the host. So in this, via this command, we'll be installing, and this repo is available in Docker CE. So let's see. So adding repo. So this repo is installed. Okay. So this repository is available now. Okay. Now what will now repository is there. Now we need to install containerd. This containerd we have to install in all the host. Well, just now we have installed this repository Docker CE. So let it install. Okay, so it will be taking some time. Let me pause the video. Now this is already installed. Okay, Since container D, container D is again a containerized. So this container D is already installed. This is a runtime environment. Okay, so now we'll be starting container. We already installed container Ds. We already installed. Now we'll be starting the services. So services is started. Again here also services is started. Okay. Now configuring system D group so that whenever container start, it start with system C group setting. Okay, so this is system C group setting. So there are some settings are required when container D start. It should start with our some of our settings. So we'll be adding those configurations. So let's find out in all the host. So container is required in all the host. So in worker 2 we have installed, worker 1 light installed. Now master 1. Okay, so container system default. Now some more setting. Worker 1, now worker 2. Okay, now since we already installed container D and its setting is done, so let restart service of container D. So container D service is restarted here. Okay. Okay. Now we'll be installing Kubernetes, but and this is a Kubernetes, and we want to install in all the hosts because Kubernetes some components which we want like Kubernetes like a kubelet, kubeadm, and kubectl. So these two kubelet and kubeadm we wanted to install in all the nodes. So that's why we need to install this Kubernetes repository. So let's check how many repositories are there. So this is Docker and rest are RHEL 9 repository. So we have not installed any Kubernetes repo. Let's install Kubernetes repo. See, this Kubernetes repo is installed here. So this repository is used while installing some more tool like kubectl, kubeadm. So current now we have installed this. We have cloned this repository. Now what we have done, we have just cloned the repository. Now we'll be installing. What we'll be installing? We'll be installing kubelet, kubeadm, and kubectl. Okay, so let install. And as I said earlier, this exclude Kubernetes means it won't be touching an existing Kubernetes one. So it will be installing this one as silently without any making any noise. Okay, so the tools are what are the tools are we installing? kubeadm, kubectl, and kubelet. So these are the tools which is getting installed. Okay, so it's installed in master server and here. So it's again installed, so it is completed. Now in all the host, so since the kubelet we have already started, so they installed kubelet, kubeadm, and kubectl we have installed. So let's start and enable kubelet service. Okay, so now we need to run the same in master host only. Now what we'll be doing in this command? This command. So this command what it does? Kubeadm init. So kubeadm is the utility which will be helping us in installing this entire Kubernetes cluster. So control plane we already discussed. What is control plane? So control plane endpoint. Endpoint means server, like where we can install. So here at Kubernetes, kubeadm is saying initialize control plane endpoint to master 01. So this is again, we already checked this one is working. So let's install Kubernetes there. Okay, so this kind of setting will be coming at the end of the installation. So we'll be copying and we'll be removing this one and I will be updating. So it's always better to update in a notepad. In case if you want, it will be going here and there, and it will be difficult for you guys to copy again because this is a token which will be requiring in next step. Okay, so here it says settings are installed. Your Kubernetes control plane has initialized successfully. Okay, so what I was saying from here, always copy. In case if it is not required, you can delete it later. Okay, so here, so what it says to start your cluster, you need to run the fol- following as a regular user. So these are the some commands. What it does it in .q folder. So it will be creating one hidden folder with the name of q. And actually main file is admin.configuration. Once you move inside the Kubernetes, etc Kubernetes and admin.conf. So this is the main file. So whosoever has this file, it's the admin of it. So this is the admin configuration file. Now it is coming to our home file and q.q folder we have created here, and this configuration is moving to that hidden file. And then again we are changing its permission. So let's run all the command, and this command is need to be installed in Kubernetes master only. Okay. So now the third command. Now we ran all the commands. Okay. Now let's run kubectl get nodes. Okay. So this is saying not ready. What it mean by not ready? So we are able to see. So this is master node. So we installed master node. Still two more servers are not in our cluster. So this one. So we've installed a master. So this one we have not added. So we need token. So once token is issued by master, and once that token will be once we when that token we apply here, then this worker node will be showing here. And again, once the master token we install here, then this worker 2 will be visible here. Okay. So let's see why it is not ready. It's showing not ready because our network setting is not installed. So like a network VNet flannel, something we need to install on the top of it. Okay. So let's start a Calico network. So we have seen here not ready. So after once we install Calico network, it will be coming as in a ready status. Okay. Let's install Calico network. See, too many. Now we can see. You can see like this is again some pods are installed here. You can see like initialization 2 by 3 container creating. So in order to monitor, so we'll be using watch command. Command will be same, just add it, watch in the starting. So you can see. Okay, so everything is running now. So in case if it's not running, we'll be using. So every 2 seconds, it will change the status. So right now you can see its age will be changing 3 minutes. So just now Calico installed. Code DNS, Cube API server, controller, proxy. So these everything were installed some 3 minutes earlier. So its status is changing. Okay. Now go to our SOP. So what we said, so some tokens. We need to get the token, and we need to go inside the worker node and install those tokens. Okay. So this is again then you can join any number of worker nodes by running following on each as a root. Okay. So let's move toward Kubernetes, and we'll be joining. So this worker node, it will be reporting to master. Again, let's worker to this token. Perfect. Okay. So in one go. Okay. Okay, here so we can see. Okay, so we can see here a master ready. This is not ready. Why? Maybe some. Okay, so maybe something is going on in it. See, all are ready now. So when it's coming from not ready to ready, some installation were in the middle. So that's why. And let's see it perfectly. So okay, so in this cluster, once we set kubectl get node, so it in case if it's a cluster of 10 nodes with one master or three master, then master node, worker node, and worker 01 and worker 02. So status is ready. So in case if it's something is coming like not ready, means it having some problem. Okay, and here what are the roles? So here no role assigned to worker 01, worker 2, but this is the control plane and it's showing its age. So master was installed earlier and now it's a version 1.3. Internal IPs are this one. And what's the OS? RHEL 9 OS. What's the kernel version? And this is a container D. This is a runtime environment. Okay, so container runtime environment. Okay, so and later on once Calico is also installed. This one is also installed. Okay. So this says this is again the end. And let's see again. Let's install some deployments. So that the deployments what we installed earlier. So what we can see, like cluster is working perfectly or not. So deployment. So these are the pod which will be running. We will be deeply discussing about it. So here we'll be checking some services. Okay, so this is all service. So I mean to say like each and everything is working perfectly. So again, okay, in the end of the session, I'll be telling you how you can remove the setting of communicating in case if you have some requirement that you wanted to take a remote of worker 01 from master, then so there are some files. So one is etc ssh sshd config. Second file is this one. sshd-config.d 50 cloud, this one. So what we have to do, we have to just put a hash on password authentication. So right now password authentication is selected as no. Okay, I'll give you an example. So this is our worker 01. I wanted to take a remote off, but it will not allow. It will give some error. Okay, permission denied. Why? Public key. Because public key is configured, these servers are configured such a public keys are required. So, okay, so we'll be going on this server and we'll be disabling the configuration so that it will not won't ask for a public key. Let's move toward this file. Go to bottom. So here we can see like password authentication selected as no. We have to make it yes. Okay, and later on let's move toward this file. Says password authentication set as no. Let's make it disable. Now once we disable it, let's restart this service systemctl SSH service. Now what we have to do, we have to change the password of this username and give any username. Okay, so this is all done. Now let's take remote of this machine. See again, it's not shown anything. So we are able to get inside worker 1 and see this is worker 01. Okay, then we can once we have EC2, because again EC2 user is the user which having a admin permission, we can sudo inside it and we can run from worker 01. But earlier it was not possible. And what is the benefit of it? Once we are able to get inside from Hope, you can remove the IP like elastic IPs. So here what we have used three elastic IPs. So in case if we are using elastic IPs, then sometime we'll be using elastic IPs or public IPs, then we can remove the public IP. Okay, so this is all about, but once you go inside, just take exit couple of times, else master won't come. Okay, so now we are in master, so we are good with this lab, and hope you enjoyed the session. Thank you and have a wonderful day ahead. Thank you. Bye bye. In the next session, we'll be going with AWS. AWS is already covered, so Kubernetes on VMware. Thank you.